Hello, my name is Brian, and today we're going to introduce limits. And in this video, we're going to focus on limits numerically. So let's take a look at a graph. We have 1/2 x squared down here plus 1. Now, if I were to ask you what is f of 2, all right, you'd go find the x value of 2. You would probably do a dotted line up to the point on the graph and then go over. Now that's 1, 2, and 3. So based on the graph, it looks like f of 2 is 3. You can also figure that out by plugging x equals 2 into here. The problem is that that's not a limit. And in a lot of the easy examples, by plugging 2 in, ends up being the limit. I haven't actually defined limit yet, but right now what we haven't done is a limit. All right, it's just a function value. All right, so let's go back to the graph. And limits are asking the following question: what do you expect, right? What do you expect the y value to be as x approaches 2? So if you go back down to 2, right, and that's exactly at 2. So that's exactly at 2. So what happens if I pick x values close to 2? Like right here at like 1.75. Or how about at 2.1? If you were to pick x values close, what were their corresponding y values be close to? And based on the graph, they all look like they're getting close to 3. So that's what common sense says, is if I were to plug x values close to 2, you would get y values close to 3. So let's take a look at a graph. We're going to, same graph, but we're going to set up a table. Now I have a left hand and a right hand side. All right, you're gonna see these again in later videos. So what I'm gonna do is I'm gonna plug in x values slightly to the left, hence why we called it the left hand column, slightly to the left of 2, and then in this column slightly to the right of 2. So some x values slightly to the left of 2, we can say like 1.75, and then maybe 1.9, then 1.99, 1.999. All of these are slightly to the left of 2, and notice that they're increasingly getting closer to 2. And then if I chose x values slightly to the right of 2, I could choose something like 2.5, and then maybe 2.1, 2.01, 2.001. Again, notice that they are all getting very close to 2, but not exactly 2. All right, so I'm going to make the table look a little bit nicer. What I'm going to do now is I'm just going to go ahead and plug in 1.75 into my function and get the y value, and I'm going to do that for each one of these. Just to show you how I would do this on a calculator, I'm going to pull one up and show you how I do that. So here I have my graph in calculator. Let's go ahead and turn it on. I have it set on the function 1/2 x squared plus 1. I graphed it. And then if you press second and then trace, you're allowed to choose this option, which is value, which basically just says plug in an x value. Start with 1.75. So I'm going to get 2.53125. So I'm just going to round that. So let's come back here. I'm going to get 2.531, what did I say, 3. And let's do 1.9. So let's go ahead and get 1.9. And I get 2.805. Let's go back here, 2.805. Let's just do one more. We can do 1.99. That gives us 2.98005. So I guess I can round that to 2.9801. And if you keep doing this, you're going to get 2.998, and then 2.99, I think one more 9, and 8. So notice that as x is getting closer and closer to 2, and this is again from the left, the y values are getting really, really close to 3, which is what we expect from by looking at the graph, right? When x is getting close to 2, you can see that the y values are getting close to 3. So we're going to do it again with x values slightly to the right of 2. Now, again, if I were to just go and plug values like that again, like 2.25, I'm going to get this y value of 3.5313. All right, so I'm just going to fill out the rest of the table. Okay, now that the right-hand side is filled out, if you notice as x gets really, really close to 2, but now from the right-hand side, your y values are getting closer and closer to, as you guessed it, 3. Okay, so that's how we would determine a limit from a table. Now let's talk about notation. So what did we learn? As x gets really, really close to 2, the y values got really, really close to 3. So the official notation for a limit would look like this. All right, so that's what LIM stands for, is limit. Now this notation here says as x approaches a. So as x gets really, really close to some x value, and this is your function, this is what the y values are getting close to. Y values get close to L. So as you take your function, let x get close to a, your limit value L would be whatever the y value is, whatever the y value you're getting close to. So for us, the limit of, and this was our function right here, 1/2 x squared plus 1, as x got close to 2, we saw that the y values were getting close to 3. All right, now just the way that it's spoken, right? This is how it's written mathematically, and if you wanted to say it out loud, you would say the limit of f of x as x approaches a equals L. So for us, when we had our graph and we said, what's the limit as x approaches 2, you would say the limit of 1/2 x squared plus 1 as x approaches 2 equals 3. So that's just our brief introduction on limits. Again, it's what do you expect the y value to be as x gets really close to 2 from either side. And when we do that, we noticed it got close to 3. So 3 is right there. So for some more examples, we have these two right here. And if you would like to see the solutions to these examples, you can find the solutions and more information about NIU at the following link down here.